Hi there, this is Kylie Bagley Ferner, and this is my final project for ECN 240 online. My teacher is Brother Tucker, and here we go. So this is the preview of the welcome page, and this is awesome because it gives an introduction to a little bit of what the tutorials are, and then it has a link to each one. So the first one we can look at is stacks. So as you can see with each tutorial, I keep a similar structure. I start with an introduction, then I give some form of example, usually with a diagram. So for stacks, I compare the to a stack of pancakes, how if there's a stack of pancakes, you're not going to pull the one from the bottom because the whole stack would fall over. And then it moves on to the undo function, which is also similar to how stacks work. And then here there is a table with each operation in Python that you need to learn for stacks and what they do. And then finally it moves on to an example, which is an example that takes a word and writes it backwards. And then moving on to the problem to solve, I decided to make a problem where it is similar to like a Netflix recently watched list, where it doesn't show what you watched first, but it shows what you watched most recently, or in other words, last, and that's how it works. And then I have my example code, which is this link right here for the solution. We can just go back to that preview, and at the top of every page, go back to the welcome page. Can go to the next one, which is sets. And again, the introduction. And the most important thing with sets is it doesn't allow duplicates. That's something that makes it pretty unique. And it's very efficient. Most of the code in sets uses an O1 time. So one of the first things with sets is hashing. And hashing is one of the ways that it is able to achieve the O1 operation, which is very efficient. And how hashing works is it keeps an index. So if our index, like in this table shows, was 0, 1, 2, 3, 4, 5, then as we receive the numbers, they go into their matching index, and there can be gaps in the list. And that is also something that makes it different from stacks or lists, is that there can be gaps in the index. And then moving on to the next part of hashing, the more complicated problem is storing larger numbers. And what can happen with this is there can become conflicts in the index. And there are two different ways to deal with conflicts. There is open addressing, where it just searches through and finds the next available index. But probably the better way to deal with it for less conflicts is chaining. And how chaining works is it just adds a list of values that go into the same index, as you can see like this. And then just like the stacks one, there's an example. And for this, I just kind of walked through how to create a set, print a set, how to remove something from that set, clear it, and then a little example of how to do a union and intersecting. And then it can be done simply, or it can be done with for loops. And then I did a problem to solve, which is to find the difference of the sets. So instead of the intersecting where it's the same thing, you find the difference. And I included in the solution a couple ways to do this, which is you can use the minus operation or the built-in difference operation, but I encouraged the student to use a for loop, as that is a bit more challenging and probably a little more rewarding. And then finally, the last tutorial is trees. So there are a few different kinds of trees. There's just the basic binary tree, and I walk through all the different parts, the root, which is the top one, and then leaves are nodes that do not connect to anything else besides their parent. And then parent nodes are anything that have these children nodes, and the child nodes are something that's coming off a parent. And as you can see here, trees can also have trees underneath, which are called subtrees. And then the next part is a binary search tree. And this kind of tree, the data is organized. So what happens is if there is a larger number, it gets placed to the right, and if there's a smaller number than the parent node, it gets placed to the left. And this way it keeps it more organized and has a better performance. And then even better than binary search trees are the balanced binary search trees, where there are a couple different algorithms to keep a balanced binary search tree, and one of the ways is the AVL. I'm not quite sure how to say that. And what this does is it will reorganize the tree if one side gets significantly larger than the other. And here are the different operations that we need to learn and their performances. Then I give an example problem. So this example problem creates the class for the tree, and there's a class inside of it, shows us how to initialize the tree, and then there's the insert, which would have been like the problem to solve. And it is already solved, and here's a way to test and what the results should be. And then for the problem to solve, there is the contains function. So I give a little bit of code already and the test with the result of what it should be when I test the contain. And these will just have to be added on to this code up top because this code up top initializes the tree. But there's nothing solved in the contain function, as you can see, but in the solution, there is a working contains function that can be added. But like I said, it will not run by itself. It needs the other code from the first section. And that is my tutorial. Thank you.